All right, so welcome back to the Civil FE exam review. Today in this video, we are going to be looking at and continuing our geotechnical engineering section. If you have not checked out the videos that I've made previously for geotechnical engineering, which includes index properties, classifications, phase relations, laboratory of field tests, and so much more, then make sure you check out those videos. Today, we're looking specifically at this part G, which is bearing capacity. So got some practice problems that I want to go ahead and jump right into. All right, so number one says, using the following information, what is the ultimate bearing capacity? All right, so you got cohesion, to be 30 kilopascals. We got a width factor. We have effective unit weight. We have foundation width, which is equal to 1 meter. We have a depth factor, which is equal to 1.2. We have a width of the width of the foundation, which is 3 meters, and we have the shape factor, which is equal to 0.2. All right. So what information do they give us? They give us all values shown up above. It'll be a lot to rewrite all of these variables, right? We have them visually to see there, right? And this is for a foundation, right? Because it gives us our width of our foundation. And we're trying to find the ultimate bearing capacity. Ultimate bearing capacity. So what formulas might we need for this? Well, I don't know. This is a bunch of mess to me. Like, I just see a bunch of stuff that I don't know what to do with this. I'm just going to search ultimate bearing. Bearing. All right, and two things come up. And the first one is ultimate bearing capacity, where it's denoted by Q ult. All right. Okay. So then I start looking and I start seeing, okay, what is C? C is cohesion. All right. Do I have cohesion? Yes, 30 kilopascals. Okay, NC, what's that? The bearing capacity factor for cohesion. Do I have that? 5.14. Okay. Do I have Y prime bar, the effective unit weight? I believe that's what that is. But so effective unit weight, yes, is a Y bar. So I'm just looking at my handbook just to make sure these symbols match up with the information that I'm given. All right. DF is the depth of footing. Our foundation, we have that to be 1.5. What about NQ? Bearing capacity for depth, or capacity factor for depth, NQ. Ours is 1.2, so we have that. Okay, plus 1/2. We have this. B is the width of the footing. The width of my footing is 3 meters. Okay, and then NY, or bearing capacity factor for unit weight. Ours is 0.2. Okay, so we have everything that we need to get this ultimate bearing capacity, which they want in kilopascals. So let's write out our equation and then solve. So we have Q, make it a baby Q. Q ult is equal to C NC plus Y prime D sub F N sub Q plus 1/2 Y sub prime B, N, Y. Okay. So now we just plug and chug. So now it's going to be Q ult is equal to, what's my C? 30 kPa times what? NC, which is 5.14 plus, what's my Y prime? 16 kilonewtons per meter cubed times a D to F 1.5 meters times N sub Q times 1.2. Okay. Plus 1 divided by 2 times Y prime, which is 16 kilonewtons per meter cubed, and then times B times 3 meters, and then times my N to Y, which is 0.2. Okay. So when I do all that, notice my units. So this cancels just to be a M squared, right? And then kilopascals, kilonewtons over meters squared, and then this one cancels to be meters squared as well. So key thing to note here is that 1 Pascal is equal to 1 Newton over meter squared. Where am I getting this? If you go to your unit conversions and you get a little bit confused, right, then just go to your bookmarks, hit unit conversions, and now you will see that they give you this information as well. So 1 Pascal here is equal to 1 Newton over meter squared. Right. So it's in your handbook as well, but if you remember it, it'll be a lot easier. So that means if 1 Pascal equals 1 Newton over meter squared, then 1 kilopascal, so you're just multiplying by 1,000, is equal to 1 kilonewton over meter squared, right? And so now that we have, notice our units, we have kilonewtons over a meter squared, right? Another time, that's why I did that. So kilonewtons meter squared, right? So that is another way of saying kPa. So we know that our units, ultimately we just want to make sure that units work. And so your Q ult is going to equal 187.8 kPa. Okay, and that is equal to A. All right. Let's look at number 2. And these ultimate bearing problems aren't going to be tough. They are just going to challenge you on knowing and making sure that you're plugging and getting your right units and things like that. So, because if that unit conversion was different, right, then totally it would have been a totally different answer. So just making sure you're putting your units correctly is key. All right, so number 2 says, using the following information, what is the width of the footing? So they give you Q ultimate, they give you, which is 200 kilopascals. They give you C, which is equal to 0. They give you NC, Y prime, df nq ny. And so we have to find the width of the footing. So let's look up width of footing. I don't know if it's going to be called a footing. Let's look up ultimate bearing capacity, because that's what this is. Ultimate bearing. So ultimate bearing capacity, right? So they give us QU, which is the ultimate bearing capacity, which is 200 kilopascals. They give us C, which is 0. They give us NC. They give us our let's look up what Y bar is. I think we did this in a previous example, but I just want to make sure you know where I'm getting some of this stuff from. So Y bar, I have to search and look through this handbook, right? Y bar is equal to the effective unit weight. Okay, so back to our equation that we're going to need. It's going to be the Q ult. All right, we're given df, we're given nq, given y bar and b, or we're not given b. B is going to be the width of your footing, right? And in y, we're given ny to be 0.2, right? So, all right, so let's write out our given information. Well, I'm not going to rewrite all that. Shown above. We're trying to find the width of the footing. Anytime you're dealing with ultimate bearing capacities, footings, this is going to be your go-to equations. Okay, so the formula we need is Q ult is equal to, just put this, B is equal to question mark. So we don't know what B is. So Q ult is equal to C NC plus Y bar D sub F NQ plus 1 over 2 Y prime times B in Y. All right, so let's solve for the values that we have. So we have 200 kPa is equal to, what is C? 0 times 5.14, which doesn't matter because you're multiplying it by 0, but plus your 20 kilonewtons per meter cubed, okay, times df 1.5 meters times 1.2, which is a factor. Okay, and then plus my 1/2 times my 20 kilonewtons per meter cubed times my B, which is what I need, right? And then what else am I looking for? Oh, the NY times my NY, which is 0.2. Okay. So now, once you move everything, adjust everything over to the other side, you're going to be left with B equaling roughly 82 meters. That's your unknown, right? So answer is D. All right. Let's look at number 3. So what is the cohesion of the soil given the following information? So we got Q ultimate, we got NC, we got Y prime, we got DF, which is the foundation width, we got depth factor, we got the width, the foundation, we have NY. Okay, so we're given the data above, ton of values, right? And we are trying to find the cohesion of the soil. All right. And so knowing that they give me, you have to have a little bit of background knowledge, right? Because you need to know that you're going to be, if you're giving Q ult, then you may need the ultimate bearing capacity. And if you don't know how to get to it, search ultimate bearing. It should be the first thing that pops up, ultimate bearing capacity. So formula is needed. So they give us the Q ultimate. C is what? Well, C is going to be our cohesion of the actual soil. And C, are we given that? Yes, it's the width factor. Are we given Y prime? 16 kilonewtons per meter cubed. D sub F is 1.5 meters. NQ 1.2 plus a half. Okay, we know Y prime, our effective unit weight, is 16 kilonewtons per meter cubed. What's our width, or B, is 3 meters. And then N sub Y is our shape factor, which is 0.2. So the only unknown is C, right? So if we write this out, Q ultimate is equal to C times NC plus Y prime D sub F NQ plus 1 over 2 Y prime B N sub Y. Okay, so Q ultimate is going to be 185.4. kPa, which is equal to C, which is our variable, right, that we're trying to find. C, cohesion of the soil, times NC. NC is 5.14. Okay, plus Y prime, which is 16 kilonewtons per meter cubed, times 1.5 meters times 1.2, which is my NQ factor. Okay, plus a half times Y prime again, which is 16 kilonewtons per meter cubed. Okay, times B, which is the width, foundation, which is 3. And then times NY, which is 0.2. All right, and when I solve and get everything to the other side, when I solve for C, I get C is equal to 29.5 kPa. All right. So these are not super tough. You just need to know what you're solving for. Right? In this case, in this ultimate bearing capacity equation, I was looking for C. Trying to highlight it. Looking for C. We're trying to find cohesion of the soil. What is the cohesion of the soil? All right, so just need to be clear on what you're solving for, and based on the information they're giving us, also having a good idea of what Q ultimate means, ultimate bearing capacity, because you're not going to be able to type that in the handbook. So being familiar with these factors and symbols and seeing this before is going to really help you. All right, so that concludes bearing capacity. The next video, we're going to be looking at different foundation types. So I will see you in the next one.